get through today for the Chapter 4 test tomorrow. All right, so Chapter 4 stuff was all of our combinations, that binomial probability theorem. We're going to see, you guys will get that formula sheet back again tomorrow that has the table of values and stuff on the back if you want to use that. All right, so number 14 says 56% of the U.S. adults say they intend to get a flu shot. You randomly select 6 adults. What is the probability that the number of U.S. adults who intend to get a flu shot is exactly 4? Okay, so this is the binomial theorem that we practiced. So it's going to start with your combination. So how many are we choosing from in this example? 6. And how many do we want to be chosen or to be successful, I guess? 4. Okay. So out of 6, we want 4 to say that they are going to get the flu shot. Then we multiply that by our probability of success, which is what here? 56%, so 0.56. To what power? The 4th. That's always going to multiply or match up with your successes on the combination there. And then we multiply by what else? 0.44. It's our Q. That's our probability of failure. So you can always do, to get that Q, 1 minus the 0.56. It's the complement. And 0.44 is going to be taken to what power in this example? It's going to be taken to the 2nd. So we have 4 successes. That's why we're doing 0.56 to the 4th, and 2 failures, 0.44 squared. And you can just type this whole thing in your calculator then. So I'm going to go ahead and do that on mine real quick. Let's see. 6 choose 4, 0.56 to the 4th, and 0.44 squared. And I get to 3 decimal places 0.286. Sound good? Okay. What is the probability that at least 5 will say they're going to get the flu shot? So at least 5 includes what numbers do we need to calculate here? 5 and 6. And we're going to have to add both of those probabilities together. So it's going to look really similar to what we just did. It's going to be 6 choose 5. Choose 5. 0.56 to the 5th this time. 5 successes. And 0.44 to the 1st. 1 failure. And then 6 choose 6. 0.56 to the 6th. And 0.44 to the 0 power. All right, and then you can just edit what you have in your calculator. Choose 5, 5th, 1st. Top one should give you 0.145. Bottom one should give you 0.031. Add them together. Final answer, 0.176. Okay. All right. Less than 4. So less than 4 includes what numbers? 0, 1, 2, 3, which we have none of those. But it is the complement of everything else, 4, 5, and 6. And don't we have all 3 of those already? So there's 2 different ways to do this problem. Whatever way your brain takes you, you can do that. I think it's easier, though, to just do 1 minus 4, 5, and 6, the probability of each of those. And then what we're left with is everything less than 4. So 1 minus 0.286, minus 0.145, and minus 0.031. 0.538. The complement of everything greater than or equal to 4. Right. Questions on that one? Okay, moving on. All right, so number 15, we are still using the information in the previous problem, but we're going to find the mean, the variance, and the standard deviation. Starting with the mean, and again, you will have these formulas. It's just your NP. What was N in the previous example? What was it? That's what you're choosing from. And P is the probability of success, which was 0.56. 3.36. Then your variance, which is your little mu squared, is NPQ. So 6 times 0.56 times 0.44. So previous answer times 0.44. And you get 1 point, again, I'll give it, well, actually this one I don't even have to round, 4784. And then last but not least, our standard deviation is the square root always of our variance. So square root of NPQ, or in this one, square root of 1.4784, which is 1.216. Mean, variance, standard deviation. Very quick little calculations on that one. Okay. Questions on 15? All right, number 16, we have probability distributions. Do you remember the two conditions for these to be probability distributions? Alex, go ahead. Okay, so the sum of all the P of X's has to equal 1. And then what about all the individual P of X's? What do those numbers have to be? All the individual probabilities. They have to fall between two numbers. There was a range.
0,
They have to fall between 0 and 1. You can't have any negative probabilities, and you can't have any probabilities greater than 1, because we know probabilities can only range between 0 and 1. Okay, so is the top table a probability distribution? Yes or no? It's a no, and you need to be able to explain why not. So why would you say no? Yeah, so negative 0.32 is less than 0, and then in words you can say there's a negative probability. Okay. What about the one in the middle? Yes or no? Again, no. 1.02 greater than 1. We need to be between 0 and 1. What about the bottom one? It looks like all of our individual probabilities are okay there. Somebody want to sum them up real quick? We're good? So if the sum of all those is equal to 1, my answer is yes. Okay. All right. So the last two examples on here are the same type of problem. We're going to do the first one together, and then I'm going to let you guys try the second one if you haven't on your own already, and then we'll put the answers up and check them, because this is probably the biggest problem, maybe on the whole test between the two parts. Number one with this, you need to be able to fill out this entire chart, and especially the column headers are what you want to remember, because those are essentially the steps to the problem. So we've got here, it's overtime hours and the number of employees that are working that overtime hour. We're going to fill out the probability of each, and then the other headings will be as follows. X times P of X. That's going to help us get our mean. Then we're going to do, what was next there? X minus our mean. X minus our mean squared. That was our deviation and our deviation squared. And then the last one is our deviation squared times, if I can fit it in there, the probability of each X value. And that'll help us get our variance when we add all those up, and that'll help us then get our standard deviation. Okay, so a lot of stuff in the calculator with these. Before I can find the probability of each event, each X value, I need to know what about all of those employees. What am I missing here? I'm missing a total. You're going to have several totals along the bottom. Sum of the number of employees is what we need to divide by. So let's see. 6, 12, 29, 57, 42, 30, and 16 give me 192. Okay. So then the probability of each X value, you're going to do the number of employees divided by that 192. Let's turn it into a decimal. 6 over 192. I'm going to give it 3 decimal places, 0.031. 12 over 192, 0.063. 29, 0.151. 57, 0.297. 42, 0.219. 30, 0.156. And 16.083. Okay. And then at the very end, all those probabilities should sum to 1 or approximately 1 because we rounded there. So you can double check that if you want to. All right, so now we're going to take each of our X's and multiply it by our probabilities. So 0 times anything is 0. 1 times 0.063, 0.063. And again, I'm just going to stick with 3 decimal places on each of these. 2 times 0.151, 0.302. 3 times 0.297, 0.891. 4 times 0.219, 0.876. 5 times 0.156, 0.78. And then 6 times 0.083, 0.498. If now we sum up that column, that is our mean. Okay, so we need that before we can do anything else. Sum of all of our x's times p of x's. And I get 3.41. So the mean is 3.41. First part of my answer. Good? All right. Now we're going to take each of our x's and we're going to subtract off the mean. I'm just going to use 3.4 just so my numbers don't get too giant here. So I'll just say approximately 3.4 down there. So 0 minus 3.4 is going to give me a negative 3.4 on that first one. 1 minus 3.4, negative 2.4. 2 minus 3.4, negative 1.4. 3, negative 0.4. 4 will give me 0.6. 5, 1.6. And 6, 2.6. So those are my deviations. Now we're going to take each deviation and square it. 3.4 squared, 11.56. 2.4 squared, 5.76. 1.4, 1.96. 0.4, 0.16, 0.6, 0.36, 1.6, 2.56, and 2.6 squared, 6.76. Okay. And then finally, we're going to take each of those deviations squared and multiply them by the probability in that row. So 11.56 is going to get multiplied by 0.031. And so on and so forth. So 0.35, I'm just going to give it 3 decimal places, 0.358. 5.76 times 0.063. 0.363. 1.96 times 0.151. 0.296. 0.16 times 0.297. 0.048. 0.36 times 0.219. 0.079. 2.56 times 0.156. 0.399. And then 6.76 times 0.083. 0.561. Okay. Sum all of those up, and you have your variance. 0.358, 0.363, 0.296, 0.048, 0.079, 0.399, 0.561. I get 2.104. So my variance, or my little mu squared, is 2.104. Second part of my answer. Okay. Only thing I am missing is standard deviation, which is a quick step from the variance. What do you do with variance to get standard deviation? Square root it. So standard deviation will be the square root of 2.104. And that is 1.451. I think that's everything it was asking for. Yes. Mean, variance, standard deviation. Oh, expected value. Expected value is the same as your mean. Okay. All right, so that's going to be the big one tomorrow. Why don't you guys try the last one then? Okay, same as this. Fill it all out, do all the calculations. I'll give you maybe like 10 minutes and I'll put the answer up and you can check it. And then the last 20 minutes are going to be yours to look at the extra practice test online if you want to, ask questions, whatever, to get ready for tomorrow. Okay, go ahead and try the last one. All right, whenever you're ready, as long as I didn't put anything in my calculator wrong, you should have a mean of about 1.7, a variance of about 1.4, and then a standard deviation of about 1.2. Vary a little bit depending on how you round it. And remember, expected value is the same as that mean. What do we think? Does this look okay? What questions do you have? This is a big problem tomorrow. It's not a big problem. You're going to do well on it. Okay. Know those column headers. Be able to set it up. That is the one thing that you do not want to forget tomorrow. All right, so the last 20 minutes are yours. There's an extra practice test on Polaris. If you want to use part of that, you can. If you want to ask questions on anything, you can do that. And we will do this tomorrow in class. All right?